Hi. So you guys can hear me, right? I'm audible, no?
Yes, ma'am.
Yeah, the meeting is also being recorded. Let me share my screen. I'm sorry for yesterday. I thought the session was supposed to be there at 8 and I kind of missed the 3 p.m. session. Really sorry. I mean, I assure you guys it won't happen again.
No issue, ma'am.
Great. Okay. All right. My screen is visible, right?
Yes, ma'am.
Yeah, great. I also fixed this pen thing. So it's kind of working now. I hope today it should be okay. Okay, so we have exam on 7th July. Okay, so I would like to give you the pattern of the quiz. So the quiz will have around 20 questions. Did someone message something?
No, ma'am.
Okay. Speak up because I will not be able to see the messages as I'm not using my laptop. Okay, if you have any questions, just speak up. You don't need, because the strength is less, right? You don't even need to raise your hand. You can just speak up. So 20 questions, 2.5 marks each, and the exam is for 50 marks. Total marks is 50. Okay, so the topics will be from week 1 to 4, and mainly the focus will be on time shifting, scaling from both ways. Suppose if you are given a signal x of t, finding a signal x of at plus b, or otherwise if you are given x of at plus b, which is y of t, from this you have to retrieve the original signal x of t. So it will be both ways. So you'll have time shifting, scaling, and you will also see the symmetries, properties of the signal. For real signals, you have even symmetry, odd symmetry, right? And suppose if you're given some signal, finding the even parts, odd parts, okay? And for complex signals, okay, finding the conjugate, symmetry, conjugate asymmetry, right? And also, if any two signals are even or odd, you guys also have seen what would be the addition of those two signals, and in case of complex valued signals, what happens to the addition multiplication when the given signal satisfies certain symmetry properties. So all those things you have seen. And also there is another thing with complex signals. Any complex signal can be written as some real part plus j times the imaginary part. And when the signal is conjugate symmetric, you have certain properties for these real. So you know this, right? So when the signal is complex signal, there are two real parts associated with this complex signal. One is the real part and the other is the imaginary part. Individually, these signals are real signals. So if when you're given a signal, if you're told that the signal is conjugate symmetric, you know how to identify whether this the two real signals that is associated with this complex signals, whether they are even or odd, you know how to find them out. So I would also recommend you guys go and check those things, work them out and see, what happens to the symmetric properties of the two real signals that is associated with the complex signal. Okay, so these are certain things you may be, so this is just a recap. So I'm not giving any specific thing. So this is just a recap on the topics that we have from week 1 to 4, which will also be covered in the quiz. Okay. So these are certain properties of the signals. Once you have them, what else have we seen? We have seen the period. Uh, did someone texted something? I could hear something. Okay. Right, and also we have seen the periodicity of the signals, periodic signal, aperiodic signal, and if a signal is periodic, we have certain things associated with it. Fundamental period, right? Fundamental frequency, this is we represented by T naught. Fundamental frequency, fundamental angular frequency. Right, so all these things are associated with the signals. So we have seen how to find if the signal is periodic or not. When we have a periodic signal, we know how to find these things. And also we have seen how to find if the manipulated signal like x1 of t plus x2 of t or x1 of t times x2 of t, we have seen how to verify if these two signals are periodic or not, provided that the given two signals are periodic, or if at all they are periodic, how to find the fundamental period of such signals. All those things we have seen in our previous lecture videos. Okay, so these are also certain things that are covered in week 1 to 4. uh, Finally, the most important topic, that is there in this week 1 to 4, or that you may be interested in remembering, are the fundamental signals. Those are defined. So by the end of week 1 to 4, any student who is taking the signals and systems course is expected to, learn these fundamental signals like rectangular function t, triangular function t. If you guys have seen your practice assignment 1, I gave some detailed fundamental signals in the beginning of your practice assignment 1. So what is a unit function? What is a ramp function? Right? What is a delta function? What is a sine function? Signum function, sine, trigonometric sine function, right? Sine of t, cosine function, tan function, log function, exponential function. So these things you guys should be familiar with. So at least by the end of, even if you guys have not seen these functions earlier in your other courses, it's always advisable to learn at least these fundamental signals during this first weeks of the signals and systems course, so that you will be comfortable in the later parts of the course. Okay, so these are certain things that were taught in the first 4 weeks, and also the topics on which you guys will be tested in your quiz 1. I hope you guys are ready. So next week is the quiz. The quiz is on July 7th. The quiz, I think, is for 180 minutes. So we have 20 questions, each 2.5 marks, and the total marks of the quiz is 50 marks, and the level of the questions will be similar to your assignment questions. So if you guys have watched the lecture videos, examples in the lecture videos. There are several examples that professor explained in the lecture videos. So if you guys have gone through the lecture videos perfectly along with the examples, and also if you guys have carefully done your graded assignments, practice assignments. So there are 4 graded assignments and 4 practice assignments, in total 8 assignments. So if you guys have done these 8 assignments perfectly along with the lecture videos, and if you guys understood the concept, and also we did some summary lectures in the live sessions, right? So those summary lectures from the live sessions, if you guys, you know, have gone through this thing, I think you are comfortable with all the contents. Any, do you guys, are you guys experiencing some disturbance? Like I hear someone
Ma'am,
texting something.
when
Yeah.
someone join, you'll get such all.
Okay, all right. Okay. So these are the things that I wanted to tell you guys. If you have any questions regarding this week 1 to 4, you can ask in this live session. So all together in today's live session, we can discuss if you have any doubts regarding your first quiz syllabus. Like if you have any questions with respect to these topics, let's work with these things. From next week onwards, we'll be entering into the different part of the course. We'll be entering, so signals will be done. We'll be looking at the systems and also analysis of the systems, and there are other things that you can do with systems, signals, everything. So those things will enter from our next week 5 content will be beginning from next week. So if you have any questions with regards to these things, you may ask now. We can discuss more on these things if you have any doubt regarding certain topic from these topics. If you need more time or more examples from any of these topics, we can do now.
Ma'am,
Mm-hmm.
I have a doubt in derivative of signals. How to calculate derivative?
Okay, derivative. So any specific example that you faced some issue with finding the derivative?
I think all the signals have basically how to find the derivative of signal. I'm not getting the concept properly.
So the differentiation, you guys are familiar with the differentiation, right?
Yes, ma'am.
So differentiation is okay. But the derivative you're facing difficulty, huh? So dx of t by dt. So this is something that you're experiencing difficulty, huh?
Yes,
Okay.
ma'am.
So you guys know this, right? Suppose, so what is dx? So we also represent this by x prime of t. So this is just dx of t by dt. How do you calculate the derivative? Is it depends on the signal. Suppose if your x of t is cos t, okay? So you know how to find the derivative for cos t, right? D cos t by dt. So this is simple differentiation of the cos signal. So what is differentiation of the cos signal? So this is basic elementary derivatives that you may have learned in your +1 +2 courses, right? Is this sin t or minus sin t? I'm confused. Hello?
Yes, ma'am.
Hello? Yeah, so
Yes,
or
ma'am.
if the given function is sin t, how do you find the derivative d by dt of sin t? This is again simple derivative which is cos t, right? Likewise, if you are given some function x of t is equal to t square plus 1, d by dt of x of t is nothing but d by dt of t square plus 1. And derivative is additive, right? So this is nothing but d by dt of t square plus d by dt of 1. And you know the derivative of t square, that is simply 2t, plus derivative of a constant is 0, simply 2t. Likewise, any example, suppose if you have a rectangular function, so rectangular of t, let your x of t be rectangular of t. Now, how is the rectangular function defined? It takes the value 1 from minus half to plus half, or minus t by, yeah, unit rectangular function is defined like this. So from minus half to plus half, it takes the value 1. So how do you represent this signal? You can represent this signal as 1 when t takes the value minus half to plus half, and 0, right, otherwise. So when you have to differentiate, take a derivative of this signal, it becomes, so d by dt of 1 when t is in between minus half to plus half, okay, d by dt of 0 otherwise, which is simply 0 for the whole signal. When you differentiate the rectangular signal, right? Or likewise, if you have a triangular signal, okay, which is defined as, so this is minus half, this is plus half. So at plus half you have 0, so it is t plus half when the signal is in between 0, or t minus half when you have half, 0 less than or equal to t less than or equal to half. So when you take the derivative of the triangular signal, what you get is you have to differentiate it from, like, part by part, which gives you this t minus half less than or equal to t less than or equal to 0, 0 less than or equal to t less than or equal to half. And when you differentiate them individually, what you have is 1 from minus half. So 0 otherwise, right? So you have 0 otherwise less than or equal to 0, and when you have 0 less than t less than or equal to half, 0 otherwise. So this is simply rectangular function. So what you got is the derivative of the triangular function or the triangular signal is nothing but the rectangular signal, right? Likewise, any other signal, the way you have to take the derivatives is try to understand and write down the signal. Maybe the simple solution is to write it down. So define the signal uh, in the domain, and then you try to take the derivatives individually. Is that okay? Who asked me this question?
Yes,
Hello.
ma'am. Okay.
Yeah, this is all right? So that's how you find derivatives. Any other signal, suppose if you are given some signal like this, say if you have some signal which is defined as some trapezoidal function, maybe this is from -1, this is minus half, this is 0, this is half, this is 1. So let me call this function x of t. Okay, so x of t is nothing but uh, so how do we, so what we have is at -1 the signal takes a value 0, and at minus half the signal takes a value 1. So minus half plus some x is equal to 1. So x is equal to 0.5. Okay. So how do we find what this is? So at 1 we have 0. Mm, at half we have a value 1. Can someone tell me what this signal is? Can you guys help me? And this what this part of the signal is. How can you? So these
We find the
parts.
slope and then this thing.
Mm,
We can find the slope and then
yeah.
slope at that point. Yeah.
Yes, I'm trying to just see what that could be.
Slope would be
Mm,
like half comma 1 and
mm.
1 comma 0.
Right. So this is half comma 1 and this is 1 comma 0. Right. So how can you find now?
So 1 minus 0 divided by half minus 1.
So this is minus 1 by zero point 0.5, which is minus 2.
Yeah.
Right. Yeah. Now, how can you find the signal? Y minus.
Uh, we basically the line equation y is equal to mx plus c.
Yeah.
Uh,
But is this the
yeah, the
signal?
y. No. The y intercept we have to find out. Like,
Or you can also find. Mm, okay, what is the intercept?
-2.
Y-intercept is also minus 2, huh?
yeah. Mm.
Is that what it is? Or plus 2? Maybe plus 2.
Plus 2. Yeah.
Okay.
Yeah.
So, okay, so this is the line. So, since this is the line, your x of t is defined as minus 2t plus 2 when you are in between. Okay, so for the guys who are not familiar with this, how to find the line equation. So let me do like a quick recap. So if you want to find the equation corresponding to this line, what you can do is you can represent the points minus 1 comma 0 and the other point is minus half comma 1, and now try to find the slope. Slope is nothing but y2 minus y1 divided by x2 minus, is that correct? Yeah, x2 minus x1. And what is your y2 minus y1? It is 1 minus 0 divided by x2 minus x1 minus half plus 1, which gives you 1 by zero point 0.5, which is simply 2. So I am trying to find the line equation for this particular thing. Okay. So m is my slope, which is 2. And how do we calculate the y-intercept, guys?
By putting the value of x and y in the equation y is equal to mx plus c.
So, okay, so we have y equal to mx plus c. So take any equation. So let me take minus 1 to 0. So this is 0, which is equal to minus 2 times 1 plus c, and hence my c is 2. So that is my y-intercept. So for this line equation, so y is simply 2 times x plus 2. So I can represent my signal as, so from minus 1 to minus half, we have 2t plus 2. Okay, so this is from minus 1 to minus half, and also in between minus half to 0 the signal is 1, So minus half to 0, the signal is 1. And from 0 to half, again the signal is 1. Okay. And from half to 1, we have seen that the signal is minus 2t plus 2. So that is from half to 1. Okay. 0 otherwise. So at any, we represent otherwise by OW, simple form. So now when you have to, like if you are asked to find the derivative of the signal, the way you have to do is you have to just do the derivative part by part. So d by dt of 2t plus 2, d by dt of 1, and then d by dt of 1, and d by dt of minus 2t plus 2, and d by dt of 0. Okay, so the range remains the same. This is minus 1 to minus half. This is minus half to 0. This is 0 to half, half to 1, and otherwise. So the final signal, when you take the derivative, it looks something like this. So from minus 1 to minus half, you have the signal taking a value 2. Okay. And from minus half to 0, the signal takes a value 0. And from 0 to half also the signal takes a value 0. But then from half to 1, the signal takes a value minus 2. There's some mistake over here. I think the signal should be, it's not, it is 2t minus 2. No, I think minus 2. Sorry, correct. So this is minus 2. All right. So minus 2, 2, and t, this is half, this is 1, 0, minus half, minus 1. So this is d by dt of x of t. Okay. Suppose if you are given this trapezoidal function x of t, which is defined like this. So if this is your given function, then the derivative of the function you can find using these steps, and the final derivative would be like this. Okay. So this is how you have to do. I hope it is clear. Any more questions with respect to calculating the derivative of the function? I think Gayatri also helped us in finding how to find the line equation in such scenarios. So the way to find any line equation is always represent the given 2 points. Okay, you can use the 2 points, and from the 2 points, your plus 2 studies will help you in finding the line equation. The slope is simply this. Once you know the slope, plug in any point or the slope in this equation and try to find the y-intercept, and the final line equation would be y equal to mx plus 2. Here our y is x of t. Okay, so our y is x of t and our x is t, hence this is 2t plus 2. Okay, so similarly you can find any line. So these things you can identify easily, but if you have to find this line, plug in the points, and using your y equal to mx plus c plus 2 calculations, you can find the line equation. Okay, so this is clear, right?
Yeah.
Yes, ma'am.
So any more questions? Even differentiation you can follow the same way. Suppose if you're asked to integration. Suppose if you're asked to find the integration of the signal, even it's a similar way. So you have to first, try to integration is a very important operator when you have to find the energy and power of the signals, right? So this is the procedure even like you guys use to find the energy or power of the signals. Try to represent the given signal in parts and then integrate it parts by part. I mean part by part. Okay.
Ma'am,
Yeah.
please take the example of rectangular function.
Rectangular function. All right. Yeah. Yeah. So we try to evaluate this, right? Like we already tried to evaluate this. So what happens to the rectangular function? So this is a constant function, but then if you see, there's a shift exactly here. So so since there is a shift over here, this is not a continuous, at these points, I think when you differentiate this rectangular function, if I am correct, you get two impulse functions at minus half and plus half.
Plus half is negative in direction.
What happened?
Ma'am, plus half in opposite direction.
Oh, is it? Okay. I'm confused. Okay. Right. So this is your rectangular function, huh? So the idea that you have to use here when you have certain things like this is, it should also be both ways. So when when you differentiate a rectangular function, if you get some signal y of t, since the differentiator is the inverse operator of the integration function, when you integrate this y of tau until t, you should be getting the function rectangular t. So that is also something you may have to verify. So for this particular signal, you know, just doing by this itself will not be sufficient because there are some edge points. So you may also have to verify if the other way is true. So when you integrate your differentiation, so integrating a 0 will give you 0, which is not giving you the original rectangular function back, right? So you may also have to see. So when you get this output, when you differentiate the function, that output, when you integrate, it should also give you back this function, at least in this case. So that is why, like, you place two impulse functions at minus half and plus half, because the impulse, it takes a area of 1 around minus half and plus half, sorry, around minus half, and similarly takes an area 1 around plus half. Okay, so when you try to integrate this function, what you tend to get is the function that is over here. So that's the idea behind this. So yeah. Any questions? So is this differentiation correct, or is it the ulta? At plus half it is 1 and at minus half it is minus 1.
No, I think it's correct.
This is correct. Okay. So the idea, this is like a special case scenario. This usually will not happen with other signals, but when you have a signal like rectangular function, when you differentiate it, it gives you the impulse functions. The reason behind it is like you may also, so this is like a special case scenario. You don't, usually you don't need to apply such special case scenarios, but this is something that you may have to, you may want to remember. Okay, so the idea is when you integrate this back, you want the rectangular function back. So that is why you place two impulse functions at minus half and plus half. Okay, is that okay?
Yes, ma'am.
Yeah. Any more questions?
Yes, ma'am. I need some clarification in correlation, means cross correlation or auto correlation.
Why is that coming here? Signals and systems, we are not dealing with them, right? Did Professor,
Yeah, Professor covered it in the last lecture, I think.
which lecture?
Lecture 6. Lecture 6.
Oh, is it? Okay, so let me go through through those topics, maybe we can discuss them in the next live session, but at least for quiz, these things will not be covered, okay?
Okay.
Yeah.
He just
So,
touched
like,
on them, I think. He didn't cover it in detail, but some he just gave
okay.
an idea.
So it is there in lecture 6, week 4, huh?
Yeah.
Okay, so usually these are not certain things that is required for us, but yeah, anyway, since professor covered, I'll go through them. We can cover it in the next lecture, next live session on Wednesday. But at least for the quiz, you guys don't need these topics, okay? We'll cover these topics in detail in next live session.
Okay.
Ma'am, I have a doubt in practice assignment week 4.
Could you tell me the question? Could you tell
Question
the question out?
okay, let's try.
There was one specific thing that I think Satyam pointed out in the last live session. Week 3 practice assignment question 10, I guess. So the answer there is wrong. So it should be conjugate symmetric. The signal should be conjugate symmetric, but then the answer says it is conjugate asymmetric. Just it's in the practice assignment, so make note of this, guys. That is correct, right, Satyam? So the answer is conjugate asymmetric, but the correct answer is conjugate symmetric, right?
Yes, ma'am.
Yeah. So this is something correction. So this is a correction. Yeah. So which question you were having doubt? So I don't know who spoke.
Question 9. Question 9 and question 10.
From which practice assignment?
4.
Practice assignment 4, question 9. So could you tell me the question out, if you don't
Yes,
mind,
ma'am.
or let
It's
me open it?
basically
I'm opening the question 9. Okay, find the right decomposition of the following signal, right? That is your question, no?
yes, ma'am.
So the signal x of t is defined as something like this, right? And then there is a unit impulse signal that is defined over here, which takes value 1. This is 1. This is 1, 2, and 3 minus 1 t. So this is the given signal. Now you have to find the right decomposition. Remember, like when we discussed about how to find the decomposition of the signals. Our thought was to break down the signals first, right? So the signal is defined as like this. So x of t is defined as 1 from 0 to t to 1, and minus 1 from 1 to 3, and there is a delta function that is defined at 3. Okay, and 0 otherwise. So this is the given signal. So this is something that is, so delta that is defined at 3, that you can always represent as, so delta function that is defined at 3, so this is always represent, you can always represent that as del of t minus 3. That is the shifted version of the original delta function. So this is set. So this part is okay. So I'll just ignore this part. So I can always split this function into two parts. The first part is something that takes in the original signal, and the second part is something that is there at 3. So this signal is simply x1 of t plus x2 of t. This is immediate from the given picture, right? So, and this is delta of t minus 3. Okay, so x2 of t is set. Now I have to find x1 of t, right? So we know how to find x1 of t. So now what is x1 of t? If I just remove this part. Oh. So this is my x1 of t. Now how do I define this signal? There are multiple ways to define this signal. You can decompose it in multiple ways. But if you want to find the right decomposition among the possible options, it is always better to verify with the options. So since you know x2 of t is delta of t minus 3, the right options here in the given problem are either 2 or 4. Definitely 1 and 3 are not correct. Okay, so right options are either B or D. And for the D, let's see what happens to D. So D is u of t plus u of t minus 3. So what is u of t plus u of t minus 3? So this is u of t, and this is u of t minus 3. When you add these two signals, how will that look like? So you have 1 up until 3, and from 3 you have a jump. You are adding 2 unit signals, so you have a jump. So this takes a value. So this is u of t plus u of t minus 3. Definitely this is not what we are looking at. So like if you are looking options wise, like you can blindly say that the options B and D are correct, but D is definitely not something we are looking at, so the option is B. But if you want to re-verify if your option is correct, we can also plot the B part, u of t minus 2 times u of t minus 1 plus u of t minus 3. So if we plot u of t, so this is your u of t signal, and 2 times u of t minus 1 is something like this. So minus 2 times minus 2, and this is still 1. So this is minus 2 times u of t minus 1. And then you have u of t minus 3. So what is u of t minus 3? Which is this. So it takes a value 1 from 3. So when you add these three parts, the resultant signal is until 1. So until 1, you have a value 1, right? And yeah, and at 1 or from 1 till 3. So 1 till 3, what happens? You subtract these two signals. So from 1 until 3, it is 1 minus 2 plus 0, which is minus 1. Is that what we want? Yeah. So from 1 until 3, we have -1. This is 1. And from 3, when you see it is, so from 3, what you have to do is add these 3. So it is 1 minus 2 plus 1, which is 0. Okay, so this is your signal. So this is u of t plus u of t minus 3 minus 2 times u of t minus 1. This is what we are wanting. So this x1 of t signal is nothing but u of t plus u of t minus 3 minus 2 times u of t minus 1. And the x2 of signal is del of t minus 3. Hence, the right decomposition of the signal is x1 of t plus x2 of t. Is that okay? I mean,
Yes,
I
ma'am.
would like to repeat, for any given signal, there could be multiple decompositions. So it is not the it is not the decomposition alone. You can also decompose the signal using rectangular functions, right? You can represent this signal as a rectangular signal, this signal as a rectangular signal. You can represent this signal as summation of two rectangular signals plus the delta signal. So there are multiple decompositions possible, but what decomposition it is, since the question is an MCQ question, it is always advisable to verify through the answers. So from the given signal, blindly you can say that definitely the options are B or D because there is a delta function at 3. And for the other part, you have to carefully verify whether it is B or D by evaluating the B and D parts, the first parts of B and D parts, okay? That is how you have to do this problem. Going to the next problem, 10th problem. 10th problem, I wanted to give it to you guys because since we did not go the other way around, so you're given a signal y of t which is minus half times x of minus 2t minus 3 by 2. So the best way to do it is always transform it into the standard form. When I try to multiply these both sides by minus 2, this is minus 2 times y of t is nothing but x of minus 2t minus 3 by 2, right? Now, let me call this as y1 of t. y1 of t is x of minus 2t minus 3 by 2, alright? So, this is of the form x of at plus b, right? Now, you want x of t. So your y1 of t is x of at plus b. You know how to go from x of at plus b to x of t. So how do you go? The transforms that you have to do, or the first step is to shift by minus b by a, and the second step is to scale by 1 by a. Or if you're going from x of t to x of at plus b, I mean, if you're given x of t and if you have to find x of at plus b, then the transforms are shift by b and scale by a. So these are the things. Or if you have to go in the reverse direction, then the transforms that you have to apply are first shift by minus b by a and then scale by 1 by a, right? So let's do the transforms. So when you shift this by minus b by a, so given signal is y of t, right? From y of t you can easily calculate. So y of t is the given signal, which is represented as follows. So you have 0, 1, 2. This is t and this is y of t. From y of t, you can calculate y1 of t. y1 of t is nothing but minus 2 times y of t. So the amplitude is scaled. So when you say minus 2, what happens to this part? So definitely from here to here, from 1 to 2, it is now plus 2, right? Okay, this is minus. This is y1 of t. Is this okay? Until here, is this okay? Need some acknowledgement.
Yes, ma'am. Okay.
So I just multiplied the amplitude of y of t by minus 2. That gives you y1 of t. So now you know that y1 of t is nothing but x of minus 2t minus 3 by 2. So now it is in the standard form. It is in the standard form, some x of at plus b, where a is minus 2 and b is minus 3 by 2. You have to find x of t from y1 of t, right? So how do you find? First step is to shift by minus b by a, which is equal to 3 by 2 by minus 2, which is nothing but minus 3 by 4. Correct? Yeah. So minus 3 by 4 is like minus 0.75, and then 2 scale by 1 by a, which is 1 by minus 2, which is minus 0.5. Okay. So how do we shift by minus 0.75? We know, like, we have to yeah.
Ma'am, actually, in this
Am I
case,
missing something?
yeah, I think this involves reflection also. So even my question was, if it involves reflection
Reflection is
also,
there. Reflection is there, but is this thing correct? Minus 3 by 2. Is that thing correct?
yeah, that's correct. But the thing, if we do it like this, we won't get the answer as it is given.
No. Inversion will come. So inversion is there because you are scaling by minus 0.5, which is a negative. So inversion will come in the later step, but
Not inversion, reflection.
reflection in the sense?
In the sense, like, see, now the signal is like x of minus 2t minus 3 by 2, right?
Mm-hmm.
So we write it as x of minus of 2t plus 3 by 2.
X of minus half.
No, not minus half. Minus x of minus brackets t
Uh,
2t plus 3 by 2.
I'm just
I'm just
checking if
uh,
the
getting the minus outside.
solution, if the answer given is correct. So I think, hold on. So okay, let me evaluate it by the standard steps. So I'm little confused with the solution, but yeah, the steps are correct. So let me go through the steps once. So shift by minus b by a is you have to shift it by minus 0.75. So how do we shift by minus 0.75? So you have to, so remember, shift by, so b is x of t plus b is nothing but we subtract that much part from the time axis. So our shift is now by minus 0.5. So it is, you know, what we have to do is we have to add plus minus, plus 0.75 to everything. So when I shift this by 0.75, the delay will produce a signal of this form. So minus 3 by 4 is 0.75 only, right? I'm not getting confused. So it's just a shift. So this is 2.75, 1.75, and 0.75 t. So this is y1 of t minus 0.75, right? Now what we have to do is we have to scale this entire signal by minus 0.5. Remember, how do we scale the signal? We divide that by 0.5. So we divide the whole signal by minus 0.5. So let me take this part. Or let me shift this. Okay. So now I have to divide the time axis by minus 0.5. So remember, this is your minus 2 and this is your plus 2. I'm just going by the steps that I have explained you guys. Nothing more I'm doing. So, yeah. Okay. So now I have to 0.75 divided by minus 0.5. This is 1.75 divided by minus 0.5. And this is 2.75 divided by minus 0.5. So how does that look like? So 75, or this is just 3 by 4 divided by minus half. So this is minus 1.5, right? So this is minus 1.5 and this is 1.75, yeah, 175 by 100 by minus 5 by 10. So what is this? 35, 3.5. So this point is minus 3.5 and this point is minus 5.5, right? So when you plot the final signal, what you get is from minus, so I'm just ensuring that the axis is on the right side. So from minus 5.5 to minus 3.5, what we have is a rectangular signal, right? So this part. And then until minus 1.5, what we have is this signal. So this is minus 2 and this is plus 2. So this is your x of t. Is that okay?
Yes, ma'am.
Yes, ma'am.
So what I have done is, so I'm trying to write everything in the standard form first. So your given signal y of t is minus half times x of minus 2 minus 3 by 2, right? So when I just multiply both sides by minus 2, I'm calling this signal as y1 of t, which is the amplitude scaled signal. So my y1 of t is nothing but minus 2 times y2 of t. And y1 of t is x of minus 2t minus 3 by 2. So this is in the standard form, x of at plus b, right? So y1 of t is equal to x of at plus b. You know how to go from x of at plus b to x of t. You know the operations that you have to do. First shift by minus b by a and then scale by 1 by a. So this you know. So what I have done up until here is to try to get rid of this term somehow. So I got rid of this and then made everything in the standard form. When I took this to the other side, that is y1 of t, which is minus 2 times y of t. So first operation that I am doing is y of t, I am first converting it to y1 of t by multiplying the amplitude by minus 2. Once you know y1 of t, you know how to go to x of t. You know you have to do these operations. The first operation is shift by minus b by a. So when you shift, your a here is minus 2 and your b is minus 3 by 2. Your minus b by a is minus 3 by 4, which is minus 0.75. So shifting by minus 0.75 is same as delaying the signal here. Delaying the signal by 0.75. So this signal you are delaying by 0.75, by which you get this. And then now you have to scale the signal by minus 0.5. You know how to scale the signal by minus 0.5. You have to divide the entire axis by minus 0.5. So I divided the entire axis by minus 0.5, which gave me these results. So minus 1.5, minus 3.5, minus 5.5. Now I'm just making the axis correct. So in the obtained signal, the negative axis is on the right, but in real, the negative axis is represented on the left. So I just rearranged the axis. So this is same as this with just rearrangement of axis. Once I rearrange the axis, I obtain my x of t. Okay. Is that all right? Is that your question? I mean,
Yes,
your
ma'am.
doubts are clarified, right? With respect to questions 9 and 10.
Yes.
Okay. Any more doubts? So always remember our standard steps. Don't forget them. From x of t to x of at plus b. The first is shift by b and scale by a. If you want to go from x of at plus b to x of t, first shift by minus b by a and then scale by 1 by a. Okay. So standard step, suppose if you are given some signal y of t is equal to m times x of at plus b, and if you are asked to find x of t, so given y of t, and if you are asked to find x of t, the way to do that is first try to represent this in standard form. X of at plus b is y of t by m. Now you know how to go from x of at plus b to x of t. So if you call this y1 of t, you are given y1 of t signal. So do these operations on the y1 of t signal to obtain x of t. Okay, that's all. Is that clear?
Yes, ma'am.
All right. Maybe whatever the approach Gayatri suggesting might also be correct. I'm not really sure what she was about to suggest, but I wanted to go through the standard steps I taught you since I went through this direction.
Yeah, this
Okay.
is also fine, man. This is fine.
Okay.
And somebody is asking, what is your discourse ID?
Course ID E2101.
No. Discourse. If you are you available on discourse forum? Like,
Oh, I don't know. What is the discourse?
we have for subject wise, we have something called a discourse forum.
Okay. Can you
You
spell it?
DIS course COURSE.
I'll check with the team. I'm not sure of this, but if you guys have any doubts, you can either email to the following email ID
Oh,
or so this is the course email ID, or you can also email to my email ID.
one thing is, if you can create one ID for you in discourse forum.
I will tell the team to do that. If the
Yeah.
team do not do that on time, please, make sure that your doubts are cleared before the quiz.
Yeah.
You can email to this email ID, okay?
Yeah. The advantage is if in discourse forum, if somebody posts a doubt, everybody can see it.
I see, okay.
So that's very useful. This thing.
Okay, I'll tell the team to create one ID, okay?
Yeah. Thanks, sir.
Any more questions?
Excuse me.
Tell.
I have doubt in graded assignment for question 1. What is the signal for that? I didn't understand this equation.
Okay, so let me open. I think there was some trouble with the setting, right? I think the team did not set it properly. I'll tell the team to correct it. But the signal is this. So graded assignment week 4. So even before the team set it, I would like to request any one of you guys to please take a screenshot of whatever I am writing here and try to post it either on the discourse or on your WhatsApp group so that if the team gets delayed in setting it up, the other students will have access to this. Okay, so the signal that we have given is the following. So x of t is 1 plus t, which is from -1 to 0, and then 1 from 0, 0 otherwise. Okay, so this is the signal. I think the team did not set it up properly on the portal. I'll tell them to correct it, but just in case if they are delayed, can someone take the screenshot of this and post it on your groups? The
Yes,
signal.
ma'am. I will post it.
Yeah, so this is question 1 signal. Okay. Any other
And ma'am,
questions?
in week 4 graded assignment, last question, it is given that xt, but in signal given that x1 of t.
Okay. Aha. That is error from our side. That's a correction. So week 4, question 10. Signal. Plot should have been for x1 of x of t. What we meant was x of t only, but given x1 of t, correction to x of t. Okay. Yeah. Please kindly post it on your public portal so that everybody can see these corrections. I'll also inform the team, but not sure if they have the access to edit now. But anyways, can you guys take a screenshot of this and post it on your groups? Any other questions?
And even in graded assignment, last question.
Mm-hmm.
I'm assuming that the amplitude is 1, no? The even it's not marked there.
Which one? Graded assignment week 4, 10, right?
Yeah, yeah, yeah.
It is 2, right? So
Two,
are
no,
you
no. The
are you
other
not able to see the marking?
no, 2 is fine. The opposite side.
The opposite side it is -1. Okay.
Minus, yeah.
Yeah. Opposite side marking is -1. So let me plot the signal here. Okay, so this is the signal. Yeah. Can one of you please post it on your group? These corrections. Any other doubts?
Yes, ma'am. In graded assignment 3, last question.
Graded assignment 3, last question. Okay. Yeah, graded assignment 3, last. Oh, graded assignment 3. Okay. Mm. Are the two signals orthogonal? That question, right?
Yes, ma'am.
Okay. The way to do it is one easiest approach to see the answer or to understand that question is so I would like to give couple of points with respect to the orthogonal signals. So when we integrate from minus infinity to infinity some x of t dt, okay, when we integrate this, if x of t is odd, let me call this integration sum as some s. If x of t is odd, then s is simply 0. Okay. Or if x of t is even, then s is 2 times 0 to infinity x of t dt. Because when it is even, it is symmetric on both sides, right? And you can evaluate the sum by just trying to, so you can evaluate the sum from minus infinity to infinity by just doubling the sum over one side of the axis. So that is what it is stating. So if you want to evaluate the sum from minus infinity to infinity x of t dt, if the given signal is odd, then definitely you can say that that integration or the sum is 0. Right? Integration is just the sum over all the continuous values of t. Right? So if otherwise x of t is an even signal, then you can say that this sum is 2 times the sum from 0 to infinity x of t dt. So there's a couple of points that you may have to note. Okay, so now when you look at this following signal that it was given, so you were given x1 of t, which is defined like this. So you have x1 of t that is defined like this. And then you have x2 of t, which is defined as follows. So this is your x2 of t, and this is your x1 of t. Okay. So clearly you can see that the x1 of t signal is anti-symmetric. Around 0, and x2 of t is symmetric around 0. Okay. Hence, when the signal is anti-symmetric around 0, you also know that the signal is odd, right? So x1 of t is an odd signal, and x2 of t signal is an even signal, right? And also, you know, other thing, when you multiply two signals, and if the first signal is odd and if the second signal is even, the obtained multiplication is an odd signal. This is something that we have checked in our previous live sessions. We did a summary on these things. So if you product two signals, and if one of the signal is odd and the other signal is even, then the obtained signal is an odd signal. So this is another important property that you may have to remember. And now for the orthogonality, since these two signals are real signals, we have to check if from minus infinity to infinity, x1 of t times x2 of t dt, is this equal to 0? If it is equal to 0, then the given signals are orthogonal. If it is not equal to 0, then the given signals are not orthogonal. From what we have just seen, from the property that we have written down, this product, since the first signal is odd and the second signal is even, the product is an odd signal, and you are integrating some product which is x3 of t dt, where x3 of t dt is x1 of t times x2 of t, and this is also an odd signal. And we have also seen another important property, that when you have an odd signal, when you integrate it across the entire time axis, the integration will give you 0. And so this is true. So this is equal to 0. Hence the given two signals x1 of t and x2 of t are orthogonal. So you may not be given the values, whether this is -1 or +1. I wantedly did not give you the values because I wanted to test your property skills. So it is always advisable to understand, the concepts. If you're asked to find the integration, instead of blindly doing the integration, certain techniques, right? You can always apply those techniques, and you can say, just by looking at the signal, for certain signals, you can say what happens to the integration. For examples, in odd signals case, if the given signal is anti-symmetric around 0, just by looking at the signal itself, when somebody asks you to find the integration, you can simply say it is 0. Okay, so you don't need to evaluate the entire thing. So that's the idea. Okay, is that clear?
Okay. Yes, ma'am.
Any other questions?
No, ma'am. That's all from my side. You may ask this question, Gayatri ma'am and Ramit.
That's it, ma'am. Maybe we can start it again on Wednesday, ma'am.
Okay, so Wednesday I'll also cover. So Wednesday will be going to week 5 content. But since the quiz is coming up next week, you're free to ask any questions related to your quiz topics also. I'll also cover that correlation and autocorrelation topics, okay?
Okay.
All right. Thank you, guys.
Yeah. Thanks a lot.
Yeah.
Ma'am, I posted
Thank you,
on the
ma'am.
group the corrections.
Okay, yeah. Thank you, Ramit. Yeah.
No, thank you, ma'am.
Yeah, thank you.
Have a good day.
Yeah, good day to you. Bye.